Now that we've described a number of Java functional interfaces and walked through examples applying them, let's take a look at some other properties of Java functional interfaces above and beyond what we've covered thus far. We'll be using Java's comparator interface as a running example throughout this lesson. As you may recall from walkthroughs of earlier case studies, the comparator interface is used to impose a total ordering on a collection of objects, most commonly in the context of various Java sort methods. A functional interface can optionally be marked with an annotation, @functional interface, as shown in this example. This annotation type indicates that this interface type declaration is intended to be used as a functional interface. Java compilers are obligated to generate error messages if a type that's annotated with @functional interface doesn't satisfy the requirements of a functional interface. For example, if we have two methods or more that are abstract, then it can't be used as a functional interface, with one important exception that we'll talk about in just a moment. Functional interfaces can have abstract, default, and/or static methods. Comparator is a nice example of a functional interface that possesses a broad range of methods. Its most obvious method that's abstract is the compare method, which is used to compare two objects of type T to see how they relate to each other. In a somewhat non-intuitive way, comparator also has a second abstract method, the equals method, that's used to determine whether two objects are equal, yet it's still considered as a functional interface. If you take a look at the link at the bottom of the slide, you'll read more about the reasons for this. In a nutshell, an abstract method that overrides a method that's defined in the java.lang.Object superclass, which is the root of all interfaces and all objects in Java, is not considered as part of the interface's abstract method count. So even though comparator appears to have two abstract methods, it's still considered a functional interface. In particular, although the equals method defined in the comparator interface is overriding the equals method defined in the java.lang.Object superclass, it still remains a functional interface with only one counted abstract method. Functional interfaces can also have default methods, which provide an initial definition that can be overridden or not by implementation classes. Interestingly enough, extending interfaces can't override a default method. Here's a simple example that we looked at in our earlier walkthrough of case study EX13, where we're going to apply the sort operation, and we're going to be sorting the threads list using the comparator that compares with the thread getName function, and then we'll use the .reversed default method in order to reverse the sense of the comparison. Functional interfaces can also have static methods. For example, here's the reverse order static method defined in the comparator interface. A static method provides only one implementation that can't be overridden or modified by subclasses. Here's a simple example that demonstrates the use of the reverse order static method, where we would take the threads list and sort it using a comparator that reverses the order. There are no limits on the number of default and/or static methods that can be defined in a functional interface. So that's the end of our discussion of other properties of Java functional interfaces. We've now completed the bulk of the material in this course on Java's basic functional programming features, including lambda expressions, method references, and functional interfaces. These basic functional programming features are leveraged by many other mechanisms and frameworks in Java, including the Java Streams and Parallel Streams framework, the Java Completable Futures framework, as well as more recent advances in Java, such as reactive stream frameworks like RxJava and Project Reactor.